The utilization of renewable energy sources is a considerable contribution to the EU 2020 targets, and the utilization of solid biomass for heat production is of great relevance in this regard. The market for solid biofuels is growing rapidly, and the demand for raw materials is increasing. Consequently, it is aimed at extending the raw material basis for biofuel production, covering also wooden materials of lower quality, as well as agricultural raw materials and residues. The project AshMelT supports the extension of new biofuels by introducing a new method for quality assurance for combustion appliances for the residential sector.
Es geht insgesamt darum, dass wir eine Methode erstellen, dieses
The overall objective is to create a method to predict this slagging behavior of pellets in small-scale combustion units, of various kinds of wood pellets up to more exotic pellets. This is what we want to develop.
wollen wir versuchen, zu entwickeln.
So let's start at the very beginning. What's it all about anyway concerning this slagging? Slags are residues from the combustion process, and they have a potential negative effect on the quality of the heating process.
Ganz genau, jeder kennt wahrscheinlich Schlacke von der Kohle.
Exactly. Everybody knows slag from coal combustion, that you have to remove slag after the combustion process from the boiler every day to start the next operation. It is similar with pellets. Pellets contain incombustible components, having a certain composition that is different depending on the raw material the pellets are made of. During the combustion process, temperatures above 1000 degrees Celsius occur, where parts of this ash can melt and cause problems in the furnace. This can then lead to poor performance and emissions, or, in the worst-case scenario, to a total failure of the system.
Die Emissionen oder im schlimmsten Fall zu einem Totalausfall der Feuerungsanlage führen können.
I cannot, for example, technically change the raw material so that there is no slagging. Where can I start? Which parameters can improve the combustion behavior in the boiler?
Ja, wie Sie eben gesagt haben, es gibt nur limitierte Möglichkeiten, den Brennstoff.
As you just said, the possibilities to change the fuel are limited. During the pelletizing process, it is of course possible to add certain additives that influence the slagging behavior. But even that is limited and not yet completely understood. On the other hand, if we have a fuel with a stronger tendency towards slagging, we need a combustion plant that can deal with this fuel. And this adaptation of technology is theoretically possible.
Möglich, theoretisch.
And that's a benefit for consumers and industry, because the latter can calculate cost-effective and the others can afford it then.
Es dient, also der Endverbraucher.
Of course, the end users will gain benefit from lower fuel costs that evolve from an increasing market when we expand the range of fuels.
Die Brennstoffpalette erweitern können, sind aber darauf angewiesen,
But they are dependent on the existence of quality guidelines and criteria for quality. And such a quality criterion is our AshMelT method to predict slagging in pellet combustion.
In Pellets-Kleinfeuerungsanlagen.
To analyze the combustion behavior and exploring optimization possibilities, we are not here in this hall by chance, but we face a firing in which these experiments are carried out. What exactly is it all about?
Ganz genau. Also hier im Hintergrund steht.
Here in the back there is a boiler that is at the moment operated with miscanthus pellets, and we are, for example, investigating the slagging tendency of miscanthus pellets compared to conventional wood pellets.
These miscanthus pellets are different from conventional certified pellets. What is the possible advancement of pellets through this miscanthus fuel?
Der Miscanthus-Brennstoff unterscheidet sich insbesondere.
The main differences of miscanthus to normal certified fuels are the ash content and the composition of this ash. But the method we are developing here will determine the slagging of normal certified fuels as well as that of novel and promising fuels.
Neuartigen Brennstoffen, zukunftsträchtigen Brennstoffen unterscheiden.
It depends on the results of your research. Where do you stand in this research program at that moment? Where does it lead to? What is the time horizon?
Also das Projekt geht noch bis zum Ende des Jahres 2014.
Well, the project proceeds until the end of 2014, and this method we are developing here will accompany us until then. It shall be certified and standardized and be included in labels and standard specifications like the EN Plus standard, but also an ISO standardization is taken into consideration.
Eine ISO-Normierung ist angedacht.
All projects carried out at Bioenergy 2020 Plus include several project partners at national and European level. One of these project partners is beside me now. It's Josef Radbauer. You are head of the Department for Agricultural Engineering Research at BLT. This abbreviation we need to clarify first.
BLT steht für Biomasse und Landtechnik.
BLT stands for Biomass Logistics and Technology. It's a subordinate department of the Austrian Ministry of Agriculture, where research and testing is carried out concerning logistics, agricultural goods, and also, as the core, boiler testing, the so-called type test, where emissions and efficiencies are identified. It is completed by laboratory.
Viele Dinge untersuchen.
And conveniently just around the corner.
It's almost 1.5 kilometers away from this location, situated in Wieselburg since 1947.
You came these 1.5 kilometers today to witness the project AshMelT. You are co-accounting and following. What is your interest in this project?
Wir sind einer, wie schon gesagt, der Projektpartner in diesem Projekt.
We are one of the project partners in this project, which are representing the entire EU from Spain to Scandinavia. And also to show that various resources are used in this project, raw materials and byproducts from agriculture and forestry, to examine these in addition to wooden feedstock. We are active in the agricultural sector. Byproducts like straw, miscanthus, energy crops and so on are a big issue to fill the gap. That results from higher demands in the future.
Die mehr und mehr sich ergibt, dass der Nachfrage gedeckt werden soll.
If you are a project partner, then you are hoping to get something valuable, usable or worth knowing from the project. What would it be in this case?
Since the beginning of standardization of biomass fuels at European level in 1999, I'm active there, and of course I'm interested to propose the new standard methods there. Currently, there is a method implemented that does not meet all requirements in order to make sensible conclusions, to give recommendations to the consumer about the acceptability of certain fuels for their boilers.
Well then, standardization as a guarantee for sale and consumption.
Also for the consumer, if he reads that certain pellets meet these requirements, is it okay to use them in his boiler, yes or no?
What is your specific contribution to the implementation of this project?
On the one hand, we are involved with laboratory analysis, on the other hand, with know-how about the standardization process, and also with networking in this group of experts. This standardization at European level is now lifted up to ISO level. That means at a global level, where the Austrian input is sought after by the European Union.
How satisfied are you with the status of this project? Which insights could you gain so far, leading in this direction?
It was very exciting. There are inputs from partners with new methods, so-called rapid test methods, that then take actually a very long time. The exchange with colleagues in the international sphere is very interesting. You realize that everyone puts their pants on one leg at a time, but this intellectual exchange brings much experience, and what remains in the long term are the face-to-face contacts.
The project is running until 2014. I hope you get a lot of intellectual and beneficial experience.
Thank you.
We are here in the lab at Bioenergy, and this is about the results of the tests. Mr. Schwabel, which test will we attempt to analyze?
Ja, wir haben hier die Schlackeprobe bzw. Rückstandsprobe aus einem Brennstoff.
Here we have the slag sample or residue sample from a fuel from the combustion of a wood-like fuel. As you can see, the slag is quite lightweight and crumbles easily, but despite this it can still cause problems in furnaces. And here in the lab we are now characterizing the degree of agglomeration of these slag samples and how much slag is formed.
Agglomeriert und wie viel Schlacke ist entstanden.
The testing of these samples in the vibrating machine next to us is now up to you. You are a junior researcher. What are you going to do now?
The ash sample is placed in the vibrating screen with the largest mesh size to determine the particle size distribution of the sample.
The sieves have decreasing mesh size. What can you read?
Man kann insbesondere eben ablesen, wie groß sind die Schlackebrocken.
In particular, you can read the size of the chunks of slag and how strongly they will affect the furnace. The larger and more compact the slag is, the higher the impact and the bigger the influence on the facility in terms of performance and emissions.
That means this is about the very practical application on site at the end user.
Ganz genau. Und dessen Quantifizierung, also
exactly. And its quantification, not only knocking at the formed slag to see how hard it is, but expressed in numbers.
Now all it needs is to turn on the device and track the process.
Ja, was wir jetzt hier sehen als Rückstände von dieser vorher großkörnigen Schlackebrocken.
The residues of previously large granular slag lumps that we see here are the essence of the slag, the hardest parts of the slag chunks.
Und diese Teile sind dann wirklich
And these parts are the fractions that have the strongest influence on the combustion units. They are now weighed, and the ratio of the remaining ash is calculated.
This is one of the experiments that take place here in the laboratory. The equipment that surrounds us meets all specific purposes. Let's have a look at a glance. At the moment, they are also characterizing the various slag samples derived from the combustion. A variety of fuels were tested, ranging from wooden fuels to different trees to energy crops like miscanthus and to agricultural raw materials like straw. The slag formation for each fuel is very different and needs to be considered when it comes to combustion technology.